Hello everyone. Good morning all of you. Today I am going to explain about grade 10 lesson number 10, that is about chemical bonds. In this lesson we are going to talk about two types of bonds. They are ionic bonds and covalent bonds. This is the lesson chemical bonds. Shall I explain why the atoms tended to make bonds? දැන් අපි බලමු ඇයි atoms මේ විදිහට bonds හදන්න හේතු වෙලා තියෙන්නේ ඇයි කියලා අපි ඉගෙන ගන්න ඕනේ. For the example, for explaining that one, I'm taking some examples for the explanation. I'm taking first the sodium as well as I'm taking calcium. Then I'm going to take neon. Then I'm going to take argon. If we take sodium, sodium has 11 electrons, so that its electronic configuration 281. But if we take calcium, it has 20 electrons, so that its electronic configuration 2882. The reason for getting 281 for the 11 electrons of sodium, for the first shell 2 electrons filling, for the second shell 8 electrons filling, for the first shell 1 electron. So for the third shell filling 1 electron. If we take calcium, for the first shell filling 2 electrons, second shell 8 electrons, third shell 8 electrons, and the last shell, it means fourth shell, 2 electrons filling. Neon, that is in 10th place, it contains 2 8 electronic configuration. Argon, that is in 18th place, it contains 2 8 8 electronic configuration. දැන් අපි බලමු මෙන්න මේ දෙක. ඒ කියන්නේ neon and argon. If we take neon and argon, look at the last shell. They have fully completed last shell with 8 electrons. It means already neon and argon are in stable stages. Neon and argon දැනටමත් in stable stage එකේ. 8 electrons only fill වෙලා හින්දා. But look at sodium and calcium. In the last shell of them contain sodium 1 electron, for the calcium 2 electron. It means they are not completed with the maximum number of electrons. Sodium need 8 electrons, calcium need 8 electrons for the last shell. But look at the last shell. Sodium 1, calcium only 2. 8 electrons only fill වෙලා නැහැ. For the first shell only, we can fill 2 electrons in each and every atom. But after that, after the first shell, the other shells, you should fill 8 electrons. අනිත් හැම shell එකකම 8 electrons වෙන්න ඕන. හැබැයි මේ sodium and calcium වල එහෙම fill වෙලා නැහැ. So that they have weaknesses. Because of these weaknesses, they need to make bonds. Bonds මේ විදියට chemical bonds කියන එක මේ ඇවිල්ලා තියෙන්නේ මේ weaknesses වහගන්න ඕන හින්දා atoms bonds හදන්න පෙළඹෙනවා. ඒ කියන්නේ තව atom එකක් එක atom එකක් තව atom එකක් එක එකතු වෙලා bond එකක් හදන්න පෙළඹෙනවා. ඒකට හේතුව තමයි the reason is because they don't have the stable stages. They have only the least amount of electrons than the maximum number of electrons. අන්න ඒ හේතුව නිසා මේගොල්ලෝ bonds හදන්නේ. අපි දැන් බලමු ඒ වගේ හැදෙන bonds මොන වගේද කියලා lesson එකේ ඉස්සරහට ගිහිල්ලා. What are called as chemical bonds? The attractive forces or building among the atoms or ions resulted by the rearrangement of electrons in valence shell. For the stabilizing the atoms of elements as described above are called chemical bonds කියලා කියනවා. If we take the chemical bonds, there are two types of chemical bonds as I told you. The first bond type, ionic bonds. The second type of bond type is covalent bond. Covalent. Ionic bonds, covalent bonds. Ionic bonds and covalent bonds. They are the two bonds we are going to talk. First of all, I am going to explain about ionic bonds or the covalent bonds. Write the answers like ionic bonds and covalent bonds in your tute. Then, shall we move to the next part of the lesson? Look at this one, ionic bonds. For explaining the ionic bonds, I am taking first compound as sodium chloride. Sodium chloride, formation of sodium chloride bond. If we take Uta, sodium atom. Sodium is in, as I told you previously, sodium is in 11th place of the periodic table. So that it has the electronic configuration of 281. 281. So how to draw it? Sodium in the first shell 2 electrons, second shell puta 8 electrons. But look at the last shell, antima shell lega, last shell lega තියන්නේ එක electronic එකක් විතරයි. Now you know that is unstable state. So that after removing this electron, this electron, after removing that electron into out, it's become the stable state as sodium plus. The reason for getting plus, I may plus sodium, releasing of one electron. මොනාහරි atom එකක් electrons අයින් කරනවා නම් if release electrons, that is cause for making positive ions. Then sodium positive උනේ එකක් අයින් කරපු නිසා. If it is releasing 2 electrons, it's become 2 plus. 3 electrons, 3 plus. But in here only 1 electron puta release, because of that it's become positive ion. Then sodium, this is the nucleus of sodium. So 2 electrons in the first shell, in the second shell 8 electrons. But look at what happened with the last shell. There is no electron in the last shell because of at previously released that one. කලින් එකයින් කරපු ඉඳ මුකුත් electrons නැහැ. So that how to draw, how to write the electronic configuration of sodium plus ion, that is 2,8 only. The main reason for not putting 1, the reason it released previously. This is the way of making sodium ion. So this one sodium atom, this one sodium ion. Make a 281 මුලින් තිබ්බේ. Because of the unstable situation, it released 1 electron and make 2,8 electronic configuration after becoming sodium plus. Then ඕන්න sodium ට තිබ්බා. තව electrons 7ක් අරගෙන last shell එකට stable වෙන්න. But it's not happening. The reason it is hard to do. The easiest way of becoming stable is releasing of 1 electron. එයාට 7ක් අරගෙන stable වෙනවට වඩා 8 electrons හදාගෙන එයාට ලේසි එක electron එකක් අයින් කරලා stable වෙන එක. That's why we got this situation. So draw it in your book. After that, I'm moving to form the chlorine. We are going to form the chloride ion in the next one. Okay, then next we are moving the formation, to learn about formation of chloride ion in next one. Sodium chloride compound made out of sodium plus and chloride ion. So next, after learning about sodium plus ion formation, we are moving to learn about chloride ion formation. First of all, we are going to write chlorine. What is the place of chlorine? The place is 17. So the electronic configuration is 287. So how to draw it? Chlorine, this is the nucleus. There are 2 electrons in the first shell. There are 8 electrons in the second shell. Look at the last shell, it means third shell. It has 7 electrons. So you can see it is an unstable stage. Only 7 electrons in the last shell. If chlorine need to become stable, it needs to take 8 electrons from the last shell. But only contains 7. 7 කියන්නේ stable stage එකක් නෙමෙයි. එහෙනම් so that chlorine can release 7 electron and become stable, or it can take 1 electron and become stable. The easiest way is taking 1 electron and become stable. No. හතක් අයින් කරනවට වඩා එකක් ගන්න එක ලේසි නිසා 1 electron අරගෙන මෙයා stable වෙන්න හදන්න. එහෙනම් so that it's taking 1 electron for this one, this place. After taking 1 electron for this place, what is the appearance of it? It's become chloride. It means Cl minus sign. Taking of electrons mean become anions. It means negative ions. Releasing of electrons mean that is cause for making positive ions. So releasing of taking of electrons, one of the electron is taken by the chlorine, so it's become Cl minus. So the new electronic configuration is 288. So we are going to draw it. For the first shell 2 electrons, for the second shell 8 electrons, for the last shell 1, 2, 3, 4, 5, 6, 7, like this. After taking another electron from the sodium, it's become chloride minus. Actually, this new electron is taken from the previous sodium. Sodium කලින් electron එකක් අයින් කරානේ. ඒ electron එක තමයි මේ chloride ගත්තේ. Chlorine ගත්තේ. That's why chlorine become chloride. මේ electron එක තමයි දාන්නේ. This is the way of drawing chloride ion. මේක තමයි මේ විදිහට chloride ion එක එනවා. Then we are going to draw the next one. After making sodium plus ion structure and chloride minus ion structure, shall we draw that one on the board? It means the bond. Electrostatic attraction between sodium plus and chloride ion means that is the ionic bond of sodium chloride. දැන් අඳින්නේ මෙහෙම. This is sodium plus. Only it has first shell 2 electrons, second shell 8 electrons. It's become plus. This is sodium. Sodium plus actually. Then there is another one, that is chloride. So chloride has 3 shells. So shall we draw it? For the first shell 2 electrons. For the second shell 2 electrons. 8 electrons. For the last shell again 8 electrons. Getting minus. That is chloride. So you can see on the board the sodium chloride compound. Which compound? Ionic compound. This is the sodium plus ion. This is the chloride minus ion. by combining sodium plus and chloride minus, now you can see the sodium chloride ionic bond. This is the formation of sodium chloride ionic bond. So read the next part of the Udatiyut. It means the definition of any ionic bond is in here. මේක තමයි ionic bond කියන එකේ තේරුම. The bonds formed due to the strong electrostatic attraction between the positive and negative ions produced by exchange of electrons among atoms are known as ionic bonds. What is the meaning of that one? ඒකේ තේරුම තමයි, the meaning එක තමයි, because of the atoms exchanging the electrons in between the atoms, like sodium gave the electron to chlorine. So sodium become plus, chlorine become minus. Like that, they exchange the electrons fully. හරි ඒගොල්ලෝ එක්කෙනෙක් සම්පූර්ණයෙන්ම electrons දුන්නා, එක්කෙනෙක් සම්පූර්ණයෙන්ම මේ electron එක ගත්තා. ඒ වගේ bond එකකට අපි කියනවා ionic bond එකක් කියලා. That kind of bond we call as ionic bond because completely remove electron and completely take that electron by another atom. So that these positive and negative with our charged ions contain strong electrostatic attraction. ඒ කියන්නේ strong කියන්නේ ප්‍රබලයි. එතකොට ශක්තිමත් electrostatic charge එකක් තියෙනවා මේ දෙන්න අතර. attraction එක. electrostatic attraction එකක් තියෙනවා. ඒ මේ දෙන්න අතර තමයි positive and negative ions දෙක අතර තමයි තියෙන්නේ. Because of this strong electrostatic attraction that causes for making ionic bonds. So the answer for this place, ionic bonds. Ionic bonds. So take this one to your note. Then I'm cleaning. After that, I'm moving to the next part. Let's learn about the examples of some ionic bonds in here. You can see some ionic bonds in this place. Shall we learn about them? Sodium chloride, that is an ionic bond. Lithium oxide, also an ionic bond. Magnesium sulfide, also an ionic bond. Calcium chloride, potassium fluoride, also they are called as ionic bonds. There is a simple way to identify the ionic bonds by looking at them. The exam එකේදී MCQ part එකට එනවා select the ionic bonds කියලා. So if you get that kind of question, how to find that one easily? කඩපාඩම් කරන්න නැතුව ටිකක් ඒක simple විදිහට හොයන method එකක් තමයි මෙන්න මේක. Sodium chloride I am drawing on the board. Sodium chloride. It means common salt. Look at sodium. That is a metal. Look at chlorine. That is a non-metal. Normally, when combining metal and non-metal that causes for make an ionic bond. Metal එකකුයි non-metal එකකුයි set වුණාම එකතු වුණාම හැදෙන්නේ ionic bond එකක්. ඒක තමයි අර පොඩි hint එකක් දෙන්න පුළුවන්. ඒ වගේ හැබැයි not in every time. Most of the times this happen. Shall we take another one? Lithium oxide. Lithium oxide. Lithium is a metal. Oxygen is a non-metal. Non-metal. So by combining metal with non-metal, as I told you, make an ionic bond. ඒ විදිහට තමයි අපි මතක තියාගන්න. Examples copper sulfate. තව examples තියෙනවා. Copper sulfate, calcium carbonate, ammonium chloride, ammonium nitrate. මේ වගේ examples තියෙනවා. These are the examples of ionic compounds. Now we know what are the answers. Shall we move to the next one? Let's learn about ionic lattice. Ionic lattice. After learning about ionic bonds, we are moving to the ionic lattice. Ionic lattice. Then normally we ionic bonds හැදුනට then sodium chloride we know that is an ionic bond, ionic compound. It contains an ionic bond. This is an ionic compound. Make ionic compound. හැබැයි මේ ionic compounds, most of the ionic compounds තියෙන්නේ ionic lattices විදියට. ඒ කියන්නේ complex structure එකක් විදියට. සංකීර්ණයි. අපි බලමු මේ complex structure එක කොහොමද හැදිලා තියෙන්නේ කියලා. The arrangement gives rise to the crystal lattice of ions. මේ ions තියෙන්නේ crystal lattice වල. හරි? lattice එකක් වල. That is upward. So that these ionic lattices, these lattices we call as ionic lattices. මේවට කියනවා ionic lattices. Ionic lattice. The arrangement gives rise to the crystal lattice of ions is called as ionic lattice. Ionic lattice එකක් කියලා කියන්නේ මෙන්න මේ වගේ arrangement එකකට. This kind of crystal arrangement, crystal lattice arrangement. So that for explaining that kind of thing, I am taking the one and only and also the common thing we can find out in the nature, that is sodium chloride. ඒක තමයි මම අද ගන්න. How to make sodium chloride ionic lattice. අපි බලමු ඒක කොහොමද හැදෙන්නේ කියලා. පුතා, in this structure you can see actually the ionic lattice of sodium chloride. පුතා, in this structure you can see පුතේ red colored and blue colored circles here. Actually they are sphericals. So actually then මේක කොහොමද මෙහෙම තියෙන්නේ කියලා බලමු. මේකෙම කොහොමද sodium chloride තියෙන්නේ කියලා බලමු. පුතේ, in this structure around one sodium ion, it means sodium plus, contain puta 6 chloride ions. 6 chloride ions. Cl minus, Cl minus, Cl minus, Cl minus, Cl minus, Cl minus. Look at around 1 sodium plus ion contain 6 chloride ions. 1, 2, 3, 4, 5, 6. Right there. So you can draw that structure in your puta. This structure you can draw in the corner. Like that, ඒ වගේම අපි අනිත් එකට ගියොත්, ඒ කියන්නේ මේ ස්ට්‍රක්චර් එක විතරක් නෙමෙයි, මේක ඇතුලේ තියෙන මේ ස්ට්‍රක්චර් එක මේ විදිහටත් තියෙනවා. ඒ වගේම මේ තව විදිහකට තියෙනවා. ඒක තමයි I am cleaning this one. Around 1 chloride ion, there are 6 sodium plus ions. Sodium plus ions, Na plus, Na plus, Na plus. Look at around 1 chloride ion, 1, 2, 3, 4, 5, 6. 6 sodium ions. ඊළඟ තමයි chloride ion එකක් වඩේ sodium plus ions 6යි. sodium plus ion එකක් වඩේ chloride minus ions 6යි. ඒ විදිහට තමයි structure එක තියෙන්නේ. That is the structure of sodium chloride ionic lattice. That is very important. That will ask in the examination. මේකත් අඳගන්න. Then I am moving to learn about. Shall we move to learn about? Then we are going to learn about covalent bonds. Covalent bonds ගැනයි ඊළඟට අපි ඉගෙන ගන්න යන්නේ. Covalent bonds. Covalent bonds. Then previously පුතා we learned about ionic bonds. Actually ionic bonds are forming පුතා by sharing electrons completely. Sorry. Ionic bonds are forming puta by completely giving electrons and by completely gaining the electrons. Those bonds we talk about puta in the previous section. Ionic bonds. දැන් අපි ඉන්නේ covalent bonds වලනේ. ඒතර covalent bonds වලයි ionic bonds වලයි තියෙන වෙනස තමයි in the covalent bonds atoms tend to share the electrons. මේකෙදි වෙන්නේ electron share වීම. අර කලින් එකේදී උනේ completely giving or completely taking of electrons no. But in here we are going to talk about the sharing of electrons to become stable. මේ bonds වල තියෙන speciality එක තමයි හැම වෙලාවෙම atoms බලන්නේ always atoms tend to complete their large shell with maximum number of electrons. It means they tend to become stable. Stable වෙන්නම තමයි බලන්නේ. අපි බලමු covalent bonds කියන්නේ මොකක්ද කියලා මොකද? The bond that made by sharing electrons between atoms is called as covalent bond. The bond that made by sharing, highlight or underline, sharing electrons between atoms is called as a covalent bond. Covalent bond. Now I am going to explain that one by an example. First example එක විදිහට ගමු. The way of making පුතේ hydrogen H2. Hydrogen පුතේ is a kind of element, but in the nature it is in H2 form. H2 විදිහට that is the molecule. So now I am going to draw that covalent bond as a structure. අපි බලමු කොහොමද ඒක අඳින්නේ කියලා. මම මේ පේලියම මේ රෝ එකම ගන්නවා මගේ structure එක අඳින්න. First of all, we need to learn the place of hydrogen is in the periodic table. It is very easy that is in the first place of the periodic table. Hydrogen is in the first place. ඒක පළවෙනියට මේ. හරි එහෙනම් the electronic configuration is 1. So I am drawing hydrogen like this. Only one electron it has. So there is another hydrogen atom. දැන් මෙතන H2 දෙකක්. ඒ කියන්නේ H2 කියන්නේ hydrogen දෙකක්. So I am drawing another hydrogen structure. The graphical presentation of hydrogen. The dependent me hydrogen තමයි අඳලා තියෙන්නේ. There is hydrogen. So the first bond we are going to make. මේ මොකද්ද මේකද? Hydrogen has only one electron. Hydrogen has only one electron. It's an unstable state. So to become stable, Buddha, hydrogen need one electron. But there is no way of getting one electron. But these two hydrogen atoms can share these electrons. That's why I draw this structure. I make bond I made a kind of bond between two hydrogen atoms. With H2 atoms this hydrogen contain only one electron, this one contain another electron. So they shared their electrons. So around hydrogen now look at 1, 2. This hydrogen around 1, 2. Now they have completed the outermost shell by 2 electrons. Then you want to hydrogen H. Hydrogen H. It means the reason I took 2 hydrogens because in H2 contain 2 atoms of hydrogen. On H then look at the shared electrons. There are 2 electrons that share. So draw them in between them. Like this. And then this is the bond of covalent. Hydrogen covalent bond. Next I am going to explain about another covalent bond, that is HCl. HCl has an antibody. HCl, hydrochloric. So what is the first step you should do? Finding of the place of hydrogen and chlorine. Hydrogen and chlorine in the periodic table. Hydrogen is in the first place and the chlorine is in 17th place. In a hydrogen only one electron it has. Chlorine it contains 17 electrons. So electronic configuration 287 287 විදිහට තමයි ගන්න. මේ ආවදී hydrogen only one electron, chlorine 1 2 in the first shell, in the second shell 1 2 3 4 5 6 7 8, last shell 1 2 3 4 5 6 7 විතරයි. මොකද කරන්නේ? උදා hydrogen need one electron to become stable. Chlorine need another electron to become stable to make last shell with 8 electrons. And the only solution is sharing of electrons. මේ දෙන්නම share කරන්න. හැම වෙලාවෙම always one puta of the atom should provide one electron, while the other atom also provide one electron to make one bond. එක bond එකක් හදන්න දෙන්නම contribute කරන්න ඕනේ. එහෙනම් look at chlorine, last shell 1 2 3 4 5 6 7 8. Chlorine has completed its last shell with complete number of electrons. Look at hydrogen, around hydrogen 1 2 1 2 මේ bond එක නිසා 1 2 electrons දෙක hydrogen වලට. දැන් ඔක ලස්සන අඳින්න. Hydrogen like this. This is chlorine. So Cl. So shall we draw? First shell chlorine 2 electrons, second shell 8 electrons, last shell 1 2 3 4 5 6. Look at the bond. How many electrons in the bond? 2 electrons. And I then now method. This is the way of drawing HCl as a covalent bond. Now we did it. Next we are moving for the next one. Thirdly, I am going to explain about the formation of oxygen, O2. Oxygen is a kind of element, but in the nature that is in this form, it means the molecule, oxygen molecule, O2, oxygen atoms දෙකක් set වෙලා තමයි normal nature එකේ ඉන්නේ නෑ. අපි කොහොමද යවන්නේ? First of all, we need to find the place of oxygen in the periodic table, that is 8th place. 8th place na කොහොමද ඒක අදින්නේ? Electronic configuration එක 28 නෙමෙයි 26 කියලායි ගන්න. Because it has only with 8 electrons. For the first shell 2, for the second shell 6. දැන් මම බලන්න කොහොමද මෙහෙම ගන්න කියලා කොහොම වගේ ළමයි දන්නවා කොහොමද electronic configuration එක ගන්න කියලා, because we did the third lesson. Maximally for the first shell you can put 2 electrons. For the second shell 8 electrons. අනේ විදිහට ගන්න. Oxygen has only 8 electrons now. For the first shell 2, for the second shell 6. එහෙමයි ගන්න. එන යවා දිමු. This is oxygen. 1 2. Second shell 1 2 3 4 5 6. 2 and 6. Not only one oxygen, there are 2 oxygens atoms. Now first shell 2 electrons, second shell 1 2 3 4 5 6. Look at oxygen last shell. With the oxygen last shell need 2 electrons to become stable. Then higher attack this one also needs 8, but only it has 6. 1 2 3 4 5 6. Then may electrons share. 1 2 3 4 5 6 7. Now this oxygen has at the last shell 7 electrons. It's still not stable. තාමත් නෑ. එහෙනම් තව එක්කෙනෙක් එක්ක මේ විදිහට combine කරන්න. So look at what happened. 1 2 3 4 5 6 7 8 around this oxygen. Now last shell has 8 electrons. Around this one, 1, 2, 3, 4, 5, 6, 7, 8. A oxygen එක 8. Now look at after making the bond, it's become stable. එහෙනම් අඳින්නේ කොහොමද? Oxygen මේකම තමයි මෙතන ලස්සනට අඳින්න යන්නේ. Another oxygen. First shell 2 electrons. Last shell these 4 electrons 1 2 3 4 ඒ හතර ඇඳමින් මේ පැත්තෙත් එහෙමයි 1 2 3 4 හතරක් තියෙනවා 1 2 3 4. Look at this one. How many electrons are there? 1 2 3 4 in the bond. There are 2 bonds. It contains 4 electrons. This bond 2 and the next bond 2. Look at what happened at the last shell of oxygen. 1 2 3 4 5 6 7 8 completed. This oxygen 1 2 3 4 5 6 7 8 complete. This is called as the covalent bond of oxygen. ඒ විදිහට අපිට bonds හදන්න පුළුවන්. Shall we make CH4? අපි චුට්ටක් complex එකකට යනවා. Fourth one. Fourth covalent bond CH4. It means biogas. It means methane. The carbon means that is in the 6th place of the periodic table. It means first shell 2, second shell 4 for the electronic configuration. So shall we draw it? Carbon first shell 2, second shell puta 4. 4 electrons. Hydrogen. Look at hydrogen. Hydrogen puta only 1 electron it has. Hydrogen 1. But look at here. Hydrogen has only 1 electron, but in this molecule contain 4 hydrogens. Now here hydrogens අතරම අඳින්න. 1 2 3 4 only 1 carbon. Carbon has only 4 electrons at outermost shell, so it need 8 electrons. Then यहाँ මොකද කරන්නේ මේ අත් එක්ක bonds හදන්න. First bond. Look at carbon 1 2 3 4 5. Still not. Another bond. 1 2 3 4 5 6 around carbon. Still not stable. Another bond. 1 2 3 4 5 6 7. Still not. තව bond එකක් හදනවා මේ විදිහට. 1 2 3 4 5 6 7 8. Carbon around now contain 8 electrons because of sharing the electron. Around 1 hydrogen 1 2. Around 1 hydrogen 1 2. Hydrogen 1 2. Hydrogen 1 2. So shall we draw that one clearly here? Carbon first shell 2 electrons, last shell, then there are 4 hydrogens combined with it like this. Hydrogen, 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 hydrogen. For the bonds, this bond contains 2 electrons, this bond 2 electrons, 2 electrons, 2 electrons. Look at carbon 1 2 3 4 5 6 7 8. Electrons අට fill කරගෙන තියෙන carbon වලට. Around 1 hydrogen 2 electrons only. That is the way of drawing the covalent bond of CH4. ඔය විදිහට තමයි ගන්නෙ. Now let's do these examples at home. ඔයා මේ ටික ගෙදරදී තමයි කරගෙන එන්න ඕන. Fifth one, I am giving N2 nitrogen. As sixth one, I am giving NH3. NH3 mean ammonia. These are the homework. Nitrogen, draw the nitrogen covalent bond and draw the ammonia NH3 covalent bond at home. Look at, we are going to learn about as the next part of the lesson Lewis structure. The types of Lewis structures. Ekana mukada me bonds only for the covalent bonds, not for the ionic bonds. We are going to draw some structures that are in special. Mari special meva. So api eva igara ganna yan. For the following covalent bonds, draw Lewis dot cross structure diagram, Lewis dot diagram, and Lewis structure. Then me api igana gatta covalent bonds වලට වෙන Lewis dot structure එක, Lewis dot diagram එක. First Lewis dot cross structure, secondly Lewis dot diagram, lastly we are going to draw the Lewis structure. Shall we learn how to make them? Then mehima, look at this. Here in the 5th page you can see CH4, it means methane. In the next page you can see, according to the methane you need to draw Lewis dot cross diagram, Lewis dot diagram, Lewis structure, then Lewis structure features. ඔය විදිහට තමයි අපිට ලියන්න තියෙන්නේ. මෙතන මේ ස්පේස් එක දීලා තියෙන්නේ උදව්වක් විදිහට as a help for drawing dot cross structure, dot structure, and Lewis structure. Previously we need the real structure of the methane. අපි බලමු ඒක කොහොමද නිකන් roughly අඳගන්නේ කියලා. ඒ roughly අඳගන්න තමයි අපි මේ මෙතන ස්පේස් එක දීලා. roughly අපි බලමු කොහොමද අඳින්නේ කියලා. කලිනුත් අපි මේක අඳා. But it is not roughly. That is about the graphical representation of covalent bond of different compounds. A graphical presentation එක මේ මෙතන roughly අඳින එක. අපි බලමු කොහොමද ඒක අඳින්නේ කියලා. This is CH4 no. CH4. So CH4 means methane. So carbon is in 6th place. So there are 2 6 like electronic configuration. That is the electronic configuration of carbon. If we take hydrogen, it has only 1 electron at the last shell. Actually, for making the covalent bond, in previously also we use the last shell electrons only. No, ඇත්තටම අපිට උදව් වුණේ අන්තිම electrons. ටික විතරනේ last shell එකේ තිබ්බ last electron. ඒ කියන්නේ last shell එකේ තිබ්බ electrons විතරයි. For the last shell we call valency shell, as well as there is another name for the last shell that is called as outermost shell. එහෙනම් අපි valency shell එක විතරක් අඳහම ඇති rough structure එක. So around carbon there are 6 electrons at the last shell. Sorry, not 6, that is 4. I forgot it. Carbon is in 6th place now. So it has 2 4. It has 2 4 electronic configuration. First shell 2, second shell 4. Because that is in 6th place. So sorry. So last shell we need that contain with 4 electrons like this. 1, 2, 3, 4. Hydrogen is giving only 1 electron. Hydrogen only 1. Like that there are how many hydrogens? 4 hydrogens in the methane. Another hydrogen like this. Another hydrogen like this. 1 carbon and 4 hydrogens. 1, 2, 3, 4. Now we are going to make the bond of the covalent. To complete the outermost shell, it needs 8 electrons. Carbon needs 8 electrons. Hydrogen needs 2 electrons. Hey, hydrogen with rakdeka. The reason hydrogen has only 1 electron. For completing the first shell need maximally 2 electrons. All others need 8. And they are 8. Then carbon to 8 on hydrogen to the kind. So they are making a bond. 1, 2, 3, 4, 5 is still around carbon. There are 5 electrons. Another bond. 1, 2, 3, 4, 5, 6. 6. Another bond. 1, 2, 3, 4, 5, 6. 7. Another bond. 1, 2, 3, 4, 5, 6, 7, 8. 8. Now we know the structure. Around carbon there are 4 covalent bonds. And also around hydrogen only 1 covalent bond. And we make a then Lewis dot with it. Lewis dot cross විදියට Lewis structure විදියට අඳින්න යන්න. Shall I clean the board? Then we are moving. If we move to this place, I need the previous diagram, so I am drawing it. This is the thing we took. This is the rough structure of the bond, covalent. Actually, we drew this one previously. මේක තමයි ඇන්දේ. එතකොට දැන් මේකේ Lewis dot cross structure එක කොහොමද ගන්න? When we are taking Lewis dot cross structure, please take dots or cross for one of the atom. If you take crosses for the considered atom, for the next type of atom, take dots. අපි බලමු කොහොමද කරන්නේ කියලා. මම කියනවා carbon ගේ electrons වලට. For carbon electrons, I am taking both the crosses. To denote the carbon large shell electrons, I am taking crosses. එහෙනම් එයාට cross කීයද? 1 2 3 4. Crosses එයාට 4යි. 4 crosses. 1 2 3 4. Carbon is giving crosses. Then, if carbon is giving crosses, hydrogen should give which one? The dots. So, hydrogen may bond එකේ cross එක මෙයා දෙනවා. dot එක මෙයා දෙනවා. එහෙනම් hydrogen dot. This one hydrogen dot because of this. Then this one dot for hydrogen. Hydrogen is giving dot. And carbon is giving cross. Carbon giving cross. Hydrogen is giving dot. For this one, carbon is giving cross. Hydrogen is giving dot. This is the Lewis dot cross structure of carbon CH4, the biogas, methane. Look at again around carbon. 1 2 3 4 5 6 7 8. 8 completed. Around hydrogen 1 2. Around hydrogen 1 2 1 2 1 2. එහෙමයි. ඒක තමයි sharing of electrons, covalent bonds කියලා කියන්නේ. Then the Lewis dot structure, look at this, Lewis dot structure. If you know how to get this one, the only thing you need to do in the dot structure, convert all crosses and dots into dots only. Dots only විතරමයි කඳි. එහෙනම් dots hydrogen මේ දෙක වෙනවටම dots දෙක. Instead of these two dots. Instead of these two dots. Instead of these two dots. අන්න ඒ විදියට class and the same thing with dots. Then the most important part is Lewis structure. How to get Lewis structure for the methane? Draw carbon in the middle. That is carbon. Then what you need to do, for each and every bond, take dash, a dash. Hammer bond එකටම dash එකක් අදින්න තියෙනවා. This is a bond, no? One of the electron contributed by carbon. The other one is contributed by hydrogen. එහෙනම් ඒ වෙනුවට දාන්න dash එක. Carbon and hydrogen between dash. Then in between carbon and hydrogen another dash. In between carbon and hydrogen another dash. In between carbon and hydrogen another dash. මෙන්න මේ විදිහට තමයි. This is the way of drawing the Lewis structure of CH4. අන්න ඒ විදිහට අඳින්න තියෙනවා. Here there is a new thing, that is Lewis structure features. In that part we are going to talk about the lone pairs and bond pairs in the Lewis structure. If we take the Lewis structure, shall I draw it clearly? Make a lesson and the C H H H H. This is the way. So For this Lewis structure, we need to identify lone pairs and bond pairs. What are the things you are going to learn? Lone pairs and bond pairs. Bond pairs. Lone pairs mean non-bonded electron pairs. Non-bonded. Again, bond eකට අයිති නැති electron pairs. Are there non-bonded electron pairs? No. Bonds වෙච්ච නැති electrons වලට පේන්නේ නැහැ මෙතන. So lone pair 0. Non-bonded electrons pair 0. Bond pairs mean the bonds. How many bonds are there? 1, 2, 3, 4. Around carbon there are 4 bonds. So how many bond pairs? 4 bond pairs. Bond pairs mean the number of bonds. 1, 2, 3. That's a way of getting bond pairs. 4. Shall we take another example? We are going to make an easy thing. That is hydrogen, H2. It's lazy, but shall we draw the rough structure in here? Hydrogen. Hydrogen with only one electron contribute. So hydrogen in the first shell 1. Another hydrogen we need because this is H2. Like this. Now they are making the covalent bond like this. Around this hydrogen now 1, 2 electrons. Around this hydrogen now 1, 2 electrons. So how can we draw that one? As a Lewis dot cross diagram. Take 2 hydrogen atoms. Then if one of the hydrogen atom provide dots, the other atom should provide the electron as cross. මෙයා dot එකක් දෙනවා. මෙයා cross එකක්. මොමන්ද හරි. එමන්දමයි. This one is giving dot, this one is giving cross. කොහොමද හරි? මේ මන්ද හරි. මෙයා dot එක දෙනවා, මෙයා cross එක දෙනවා. That's the way. Book එකේ තියෙන මේ විදිහට. This is giving dot, this one is giving cross. කොහොමද? Then Lewis dot diagram, how to draw the dot diagram? This is the way of drawing. Lewis dot diagram එක අඳින්නේ. Instead of cross and dot, take all as dots. මෙයා dot එකක්, මෙයා dot එකක්. How to draw the Lewis structure? Instead of the පුතේ dots or crosses, take the dash. එක bond එකකට එක dash එකයි. එතන මෙතන bond එකයිනේ. There is a one bond. No? So dash in between it. So how many lone pairs? It means non-bonded electron pairs. No. Can you see any? No. මුකුත් නැහැ. එතන එකක්වත් නැහැ. Non-bonded. 0. But how many bond pairs? Bond pairs. How many bond pairs? Only one. You need to write them as Lewis structure features. ඒ විදිහට ගත්තම හරි. Next one. O2. Oxygen. We need oxygen very much. So I'm going to draw the structures according to the oxygen. First of all, we need to identify the place of oxygen. Oxygen is in 8th place. So how to write the electronic configuration? 2, 6. 2, 6. So I'm taking one oxygen. The first shell containing only 2 electrons. The second shell containing 6 electrons. So it's not completed the last shell. So take another oxygen and complete the last shell. To complete the last shell. It has only 6 like the before one. මේ වගේම එයාගේ 6 තියෙනවා. So how to make the පුතා covalent bond? Take this electron and another electron of another oxygen, the next oxygen. So shall we calculate the last shell electrons? 1, 2, 3, 4, 5, 6, 7. 7th. Not complete. 1, 2, 3, 4, 5, 6, 7. Not complete. එහෙනම් තව එකක් හදමු. By contribution of the both of the oxygen. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now you can see there are two covalent bonds for the oxygen. Shall we draw the structures according to this according to this covalent bond? දැන් අපි අදින්නේ ඒකට අපි පල්ලෙහාට යන්න වෙනවා. So shall I draw the thing we draw at the first oxygen? No need to draw the first shell. ඇත්තටම first shell එකක් අඳින්න තේරුමක් නැහැ. මේක rough structure එකක් නේ අපි අඳින්නේ. මොකද අපිට ඕන bond මේ structures අඳින හැටි විතරයි. That's why we are taking the last shell electrons. So the last shell එකේ තියෙන්නේ only 6 electrons. අර අපි කලින් අදපු එකම තමයි. 6 electrons at last shell. එහෙනම් මේ විදිහට bonds හදලා after making the bonds like this, completing the last shell with 8 electrons. ඔන්න structure එක තමයි දැන් අපි මෙතන අඳින්නේ. The reason for getting last shell electrons only because we need the last shell electrons only for these structures. දැන් මැද තියෙන shells වල electrons වැඩක් නැහැ. අන්තිම shell එකේ electrons විතරයි අපට ඕන. So how to draw it? Lewis dot cross diagram. I am taking the electrons that are provided by this oxygen as crosses. The electrons that are provided by this oxygen as dots. ඒ විදිහට ගන්න. එහෙනම් කොහොමද මේක අඳින්නේ? Oxygen. There are non-bonded electron 2 pairs. 1, 2 pairs. එහෙනම් කොහොමද අඳින්නේ? 1, 2, 3, 4 electrons. ඒක මේ විදිහට ගන්න. crosses විදිහටනේ ගන්නවා කිව්වේ මේකට. නා crosses විදිහට. I am taking this oxygen that is providing as oxygen electrons dots විදියට ගන්න. මේව dots විදියට. There are non-bonded 4 electrons. 1, 2, 3, 4. 4 electrons mean 2 pairs. නා ඒ ටික මේ විදියට ගන්න. හරි. මේක මේ. This is providing crosses. This is providing dots. Look at the in between part. Here there is a one bond. This one contributing cross. This one contributing dot. May I cross again? May I dot again? Cross dot. This one also draw cross dot. So how to draw it? This is the way of drawing the Lewis dot cross diagram for the oxygen. Shall we calculate it again? 1, 2, 3, 4, 5, 6, 7, 8. Around this oxygen, 8 completed. 1, 2, 3, 4, 5, 6, 7, 8. Around this oxygen, fully completed the last shape. Shall we draw the Lewis dot diagram? Instead of all the crosses and dots, we need to take dots only. Oxygen then dots, 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 dots. Dots, 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 dots for these dots, 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 dots. This one you can draw like 1, 2, 3, 4. Bond එකේ තියෙන electrons. මේ මතන දෙන්න පුළුවන්. That's a bond. Here. For the 2 bonds, they took 4 electrons. For 1 bond, 2 electrons. So, what I told you for the Lewis structure, take bond electrons as dashes. So, how many dashes in between oxygen? This one, 1 dash. For this one, another dash. Then non-bonded electrons draw like this. Non-bonded electrons. Then look at, we need bond pairs and lone pairs. How many lone pairs? Now lone pairs mean unbonded electrons. 1, 2, 3, 4. 1, 2, 3, 4. 4 lone pairs. How many bond pairs? 1, 2 bond pairs. Bond pairs 1, 2. देखा bond pairs 2. Lone pairs 4. Bond pairs 2. Lone pairs mean non-bonded electron pairs. Bond pairs mean the number of bonds. After learning about the covalent bonds and also the Lewis structures as well as Lewis dot cross structure, Lewis dot structure about the covalent bonds, we are moving the next part of the lesson. You need to do the drawing of nitrogen molecule like this, and also carbon tetrachloride. Change this one as CCl4 carbon tetrachloride molecule at home. You need to draw them at home. After that, water molecule, do it at home. The drawing of it, Lewis structure, Lewis dot cross diagram, Lewis dot diagram. Then, some of the covalent compounds are not fulfill outermost shell. There are two examples to learn. Very rare situation. Some of the times the covalent, when the atoms making covalent bonds, they are not filling their outermost shell. As I told you previously, most of the atoms tend to fill their outermost shell with the maximum number of electrons. ඒගොල්ලෝ හැම වෙලාවෙම බලන්නේ එයාලගේ outermost shell එක complete කරගන්න. හැබැයි මේ තියෙන මම දැන් කියන්න යන explain කරන්න යන compounds දෙක covalent bonds උනත් they are not fulfilling, the atoms not fulfilling their outermost shell. This is a very rare situation. Only you will get only 2 molecules for the examination that are not filling the atoms, the outermost shells. Look at this. This is the first one, aluminium chloride. Aluminium chloride molecule. If we draw the aluminium chloride, this is the way of drawing it. Al, Cl, Cl3. AlCl3. For the chlorine, we need to draw like this. The electrons, actually they are lone pairs. Look at, after drawing the aluminium chloride molecule, we can see 1 aluminium and 3 chlorine atoms. There are 1, 2, 3 bond pairs, while 1, 2, 3, 4, 5, 6, 7, 8, 9 lone pairs. But look at aluminium. 1 around it. How many electrons by the bonds? For one bond, 2 electrons. So 1, 2, 3, 4, 5, 6. It means around aluminium only 6 electrons contained. It means it is not fulfilling the outermost shell with 8 electrons. But look at chlorine. 1, 2, 3, 4, 5, 6, 7, 8. It's filling the outermost shell with 8 electrons. 8 electrons. Next we are moving for the PCl5, the next molecule learning. That one also not fulfilling the outermost shell with 8 electrons. Shall we see the way of drawing it? PCl5. PCl5, phosphorus chloride. This is the way of drawing. Chlorine, 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 chlorine. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It means look at phosphorus. Around phosphorus, how many electrons after making the bond? 1, 2, 3, 4, 5, 6, 7, 8, 19. It means 10 electrons contained around phosphorus. It is more than 8 electrons. But look at the chlorine. 1, 2, 3, 4, 5, 6, 7, 8. 8 electron. Around chlorine, 8 electron. This is the way of drawing it. Now you can see aluminium chloride and phosphorus chloride not fulfill the outermost shells of the atoms. Draw them in the table. Atomic lattice. We learn about ionic bonds. Then we learn about ionic lattices. Then we learned about covalent bonds. Now we are going to learn about atomic lattices. Atomic lattices in there. In some of the elements, the atoms are organized as lattice. Lattice can these covalently bonded lattices are called. Actually, these are not like ionic lattices. These are known as covalent lattices. Atomic lattices. In the atomic lattices contain covalent bonds, while the ionic lattices contain ionic bonds. The atomic lattice වල තියෙන atomic lattice වල තියෙන්නේ covalent bonds. කලින් අපි ඉගෙන ගත්තේ ionic lattice, ඒවයි තියෙන ionic bond. Atomic lattices වල තියෙන්නේ covalent bonds. So these covalently bonded lattices are called as atomic lattice. Lattices. Then write down it. Then we are going to learn very famous atomic lattices that related to element carbon. Carbon element has two atomic lattices. They are graphite as well as diamond. Graphite and diamond. We are going to learn about graphite and diamond. Look at the structures of graphite and diamond. Look at, this is the structure of graphite. Graphite has hexagonal structures like this. Actually, these dots we call as carbon atoms. Look at, carbon atoms covalently bonded with others. Here also the black dots we call as carbon atoms. They are interconnected with covalent bonds like these. These are carbon atoms. Carbon atoms. Mark it. Carbon atoms. You can see here there is a plane-like structure after making carbon atoms as covalently bonded. Then the next one also same to the before one, the above one, that is also a plane. දැන් මේ දෙකම හැදලා තියෙන carbon atoms වලින්. Carbon atoms එකිනෙකට සම්බන්ධ වෙලා තියෙන bonds වලින්, covalent bonds වලින්. Then you can see these two planes containing dotted lines. In your tube you can see that one, dotted lines. These planes, two planes interconnected by this kind of dotted lines, they are very weak bonds. Actually, the reason for drawing dotted lines to show the weak bonds. Weak bonds. These are weak bonds. So shall we take the characteristics of the graphite, the allotrophic form of graphite of carbon. Carbon වල එක allotrophic form එකක් තමයි graphite කියන්නේ. ඒ වගේම එක atomic lattice එකක්. අපි බලමු මොකක්ද කියලා. There are 3 carbons around one carbon. How can we take it? If we take one carbon atom in here, මම කිව්වා black dots කියලා කියන carbon atoms. මේ carbon atom එක වටේ මේක තියාගත්තොත්, if we keep our finger on one carbon atom, there are 1, 2, 3. 1, 2, 3 carbon atoms around one carbon. Around one carbon atom, there are 1, 2, 3 carbon atoms. So that's why the first characteristic is become there are 3 carbons around one carbon. Next one, there are layers superimposed on one the other. There are layers that superimpose one another. Layers. The forces holding these layers are weak. The forces holding these layers are weak. That's why I told you and I mentioned about weak bonds. They are weak. So one layer easily slide over the other. අනිත් එක මත ලිසලා යනවා ඒක නිසා. So that graphite used as a lubricant. Graphite කියලා කියන්නේ ලිසන සුළු ද්‍රව්‍ය. ඒක use කරන ඒ වගේ වැඩවලට. Diamond also another type of allotrope of carbon. Look at this structure. You can see the pink color dots, pink or red color dots on the board. These dots denote the previously I told as carbon atoms. මේවට කියන්නේ carbon atoms ම තමයි අර කලින් එකේ වගේම. Carbon atoms. The dots, the pink color dots we call as carbon atoms. You can see they are interconnected with lines. These lines are known as covalent bonds. Covalent bonds. But without, like in the previous one, we saw weak bonds, but in here you can't see weak bonds like before. It means graphite. Graphite එක වගේ මේකේ ඒ වගේ weak bonds නැහැ. All are interconnected with the strongly bonded covalent bonds. මේ විදිහට තමයි diamond structure එක එන්නේ. If we take one carbon atom, I told you this one dot of pink, that is known as a carbon atom. If we keep our finger on one carbon atom, how many carbon atoms around it? 1, 2, 3, 4. 4 carbon atoms. That's why here mentioned the one first characteristic as there are 4 carbon around one carbon. Next one, diamond is the natural hardest material in the world. That's why we use diamond to cut glasses. That's the natural hardest material. Artificially, there are so many materials made that harder than this one. But naturally hardest thing is this. That is story about carbon. Then we are moving to the next part. That is about polarity of bonds. Polarity එක ගැන කතා කරන්න යන්න. Polarity, after we are moving to intermolecular bonds, before that polarity එක ගැන අපි ඉගෙන ගන්න ඕන. Polarity එක ගැන ඉගෙන ගන්න එක මාර වැදගත්. අපි බලමු මොකද්ද polarity කියන්නේ කියලා. Actually polarity is generating due to the change of electronegativities of the atoms. Atoms වල electronegativity එක ගැන third lesson එකේදී කතා කරා. Electronegativity එකක් කියලා කියන්නේ if an atom bonded with another atom, the ability of attracting electrons in the bond towards an atom. Atom එකක් තව atom එකක් එක්ක bond එකක් හැදුවට පස්සේ ඒ bond එකේ තියෙන electron එක atom එකක් තමන්ගේ පැත්තට වැඩිපුර අදින ඒ ability එකට අපි කියනවා electronegativity කියලා. So electronegativity cause for this. Polarization means bearing of positive and negative charges on atoms due to dissimilar electron distribution in there. Shall we learn what happened in there? Then අපි බලමු තව දුරට මේක ඉගෙන ගමු මොකද්ද මේ කියන්නේ charges තියෙනවලු ඊළඟට කියනවා dissimilar electron distribution එකක් තියෙනවා මොනවාද කියලා. For explaining that one I am taking HF molecule. Now you know the way of drawing HF. මම ආපහු සරයක් මතක් කරන්න කොහොමද HF අඳින්නේ කියලා. Actually for explaining this one I need the Lewis structure of HF. HF වල Lewis structure එක අඳින්න කලින් අපි roughly මොන වගේද කියලා බලන්න ඕනේ. ඊට පස්සේ තමයි Lewis structure එක අඳින්න ලේසි. Hydrogen mean 1. F mean fluorine, that is in the 9th place. So the electronic configuration 27. For drawing the Lewis structures, we need the large shell electrons only. So I am taking hydrogen. It contains 1 electron in the shell. Fluorine contain at the large shell 7 electrons like this. To fulfill the last shell with the maximum number of electrons, hydrogen need one electron, while fluorine need another one electron. එතකොට මේ දෙන්න මෙයාට 7යි තියෙන්නේ, එයාට 8ක් වෙන්න ඕනේ, මෙයාට 1යි තියෙන්නේ, මෙයාට 2ක් වෙන්න ඕනේ. එහෙනම් මොකද කරන්නේ? The only solution is making a bond. Now look at what happened. Around hydrogen 1, 2 electrons. Around fluorine 1, 2, 3, 4, 5, 6, 7, 8. 8 to 9. So how to draw it? H, I told you, take the 2 electron bonds as dash for the Lewis structure. Lewis structure එක අඳිනකොට මේකට dash එකක් ගන්න. Then fluorine. Then around fluorine the outermost shell electrons, non-bonded electrons 1, 2, 3, 4, 5, 6. ඒ හය දෙනා 1, 2, 3, 4, 5, 6. මේ හය තමයි ඔහම යන්නේ. මෙයාලා තියෙන එක. Now what we need to do, this is the thing. Then we are going to mark the polarity. If we take HF molecule, then hydrogen, fluorine attracting electrons in the bond towards itself. ඊට හේතුව තමයි electronegativity එක hydrogen ට වඩා fluorine ගේ වැඩිවා දන්නවා. In the periodic table, when we move left to right, the electronegativity become increase. The fluorine ගේ තමයි වැඩි. එහෙනම් these two electrons attract fluorine towards itself. මේ විදිහට අදින electrons. Because of this attracting, fluorine is getting negative charge. Small negative charge. Small කියන එක පෙන්නන්න තමයි මෙතන delta දෙන්නේ. Again I am telling minus negative. Minus charge. Delta දාන්නේ small negative කියලා පෙන්නන. Because of that, automatically this one is become positive. Not only normal positive value, that's become delta positive. Delta negative, delta positive. Because of these charges, as I told you in the definition, positive and negative charges on atoms cause for making the polarity. Okay, hinda thamai polarity එකක් නේ. I think you can understand it. So this bond is a polar bond. The reason positive and negative charges in there due to the differences of electronegativities. So draw it in your book. It may tilt. Now I am cleaning it. The next part of the lesson is about H2O molecule, water molecule. How to draw the water molecule? Before that, we need to take hydrogen. Hydrogen is in first place in the periodic table. Oxygen is in 8th place. So the electronic configuration become 2, 6. So how to draw it? Let's draw the rough sketch. Hydrogen 1. There are 2 hydrogens we need. The reason H2O. So only one electron has one hydrogen. This one also has one electron. Oxygen, around oxygen there are 6 electrons. Always we need the last shell. 1, 2, 3, 4, 5, 6. Or H2O on the for drawing the H2O we need only one oxygen atom and 2 hydrogen atoms. Then oxygen wala 8 sampurna nahi. To fulfill the 8, it's making bonds. Look at first hydrogen. 1, 2, 3, 4, 5, 6, 7. Not completed yet. Another bond. 1, 2, 3, 4, 5, 6, 7, 8. Now it is completed. Oh no, we complete kalla. Maybe there tamai rough sketch එක. ඔක ඇඳලා හරියන්නේ. We need to draw the Lewis structure. I'm drawing oxygen first. Then there are 2 bonds as dashes with the hydrogen. Look at non-bonded electrons. 1, 2, 3, 4. So draw them. So after drawing the Lewis structure, you can see there are 2 lone pairs. 2 lone pairs. 1, 2. There are 2 bond pairs. 1, 2. That's the way of drawing. That is the Lewis structure. Then we need to mark the polarity. Because of the electronegativity change of hydrogen and oxygen, actually oxygen has high electronegativity. ඒක නිසා ඔක්සිජන් මෙතන ඉලෙක්ට්‍රෝන්ස් වැඩිපුර අදිනවා. මේ පැත්තෙත් එහෙම. In between oxygen and hydrogen, oxygen is attracting more electrons. Because of that, oxygen is getting negative small charge. Small කියලා පෙන්නන්නයි delta කියන එක දැම්මේ. Automatically hydrogen is become positive. This one become positive. So you can see positive and negative charges here. So this bond is become a polar bond. ඔය විදිහට වෙනසක් තියෙන හින්දා electronegativity change එකක් තියෙන නිසා this one become a polar bond. Polar molecule or polar bond. So that's the way draw it in your tube. The reason for learning this one is to move for the intermolecular bond section. Look at, I have printed this one on your tube. Actually you need to draw that one in here again to get a better knowledge. මේ පැත්තේ අපි ආපහු අදිමු. මොකද්ද මේ වෙලා තියෙන්නේ කියන එක බලන්න. හරි. Water contain not only one water molecule. There are so many water molecules inside water. So first I am drawing one water molecule as I draw in the previous one. මෙන්න මේ විදිහට තමයි මම water molecule එකක් ගන්න. As well as I marked small negative charge and small positive charges. මේ එක මොලිකියුල් එකක් විතරක් නෙවෙයි වතුරේ තියෙන තව මොලිකියුල්ස් තියෙනවානේ. ඒක නිසා මම තව water molecule එකක් අඳින්න යනවා. මේ විදිහට. හරි. This one also positive negative charge, positive charge. So you can see here in this water molecule contain positive charge in hydrogen. Here this oxygen, the other molecule has negative charge of oxygen. Or the positive negative magnets වල positive negative නේ magnets වල නම් unlike charges attracting together. So like magnets in here unlike charges. So unlike charges normally attract together. Unlike කියන්නේ සමාන නැති ඒවා. In a positive negative method attraction එකක්. That attraction we call as the attraction between positive and negative charges we call as intermolecular bond. Intermolecular bond. That attraction we call as intermolecular bond. මේක intermolecular bond එක. අන්න ඒ වගේ මේ පෙන්නන දේ intermolecular bonds. Look at this is a one of the water molecule that is in this shape. Okay, අඳලා තියෙන මේ විදිහට. This is another water molecule here, another water molecule, and also this is another water molecule. There are three water molecules. So you can see in there with oxygen minus charge and with the hydrogen plus charge there is a bond connecting here, and also here there is another bond like this. These bonds, it means the bonds that created between the molecules we call as intermolecular bonds or intermolecular attractions. Or intermolecular bonds or intermolecular attractions. Water wala or especially tiyanama. So that Buddha, if we take this bond in the water H2O, this is a covalent bond. Covalent bond. This is covalent. If we take the strength of the bonds in between intermolecular bond and the covalent bond, which one has the highest strength? Actually, that is covalent bond. Covalent bond එකේ strength එක වැඩි. දැන් අපි liquid water තියෙනවනේ. Then if we take water, normally liquid water contain intermolecular bonds in between the molecules. But when heat in the water, අපි දැන් වතුර රත් කරනවනේ. When water reach 100 Celsius වලට වතුර ගියාට පස්සේ මොකද වෙන්නේ? The water become liquid water become water vapor. The reason breakdown of intermolecular bonds. Intermolecular bonds කැඩුන නිසා liquid water vapor බවට පත් වෙනවා. But actually it is hard to divide or break down the covalent bonds. The reason covalent bond is stronger than the intermolecular bonds. අපි දැන් bonds තුනම ගත්තොත් ionic bond, covalent bond and intermolecular bonds. Actually, for the ionic bond contain highest strength, then medium strength for the covalent bond and least strength for the intermolecular bonds. Then මෙතන අපිට දාන්න මේ පෙන්වන්න කියලා තියෙනවා descending order of the bond strength. එහෙනම් අපි ඒක කොහොමද ගන්නෙ? Ionic bond වලට තමයි වැඩිම. Ionic bonds has the highest strength. Then the covalent bonds after that intermolecular bonds. That's the way of increasing the strength. Actually we wrote here the decreasing order of the strength. Vadima ionic, then covalent, then intermolecular. Then we are moving to the next part. Because of these intermolecular bonds in water, the water has some special properties. මේ intermolecular bonds water වලට තියෙන ඉන්නේ special properties වගේක් තියෙනවා water වලට. The first property of water is the water density. Water density is greater than ice. You may have seen if we put some ice on water, they float on water. The reason density of liquid water is greater than ice. Second one, water has high boiling point. That is the next one. Water has high boiling point. Water boiling point එක ගොඩක් වැඩි. It is similar to 100 Celsius. ඒක ලොකු වගයක්. තව එකක් තියෙනවා. You need to write these two. The next thing is third one. Water has high specific heat capacity. Water වල heat capacity එක ගොඩක් වැඩි. high specific heat capacity එක වැඩි. ඒක පොඩ්ඩක් explain කරොත් එහෙම දැන් අපි හිතමු මේක explanation එක තමයි මම මෙතන ලියන්නේ. No need the explanation, but it is better to get the explanation now. You will learn about this one grade 11. There is a lesson of heat. එතකොට ඒකෙදි මේක හොඳට පැහැදිලි කරනවා. ඒ උනාට මම චුට්ටක් කියලා දෙන්න. මොකද්ද මෙතන කියන්නේ? If we take පුතා 25 Celsius of water 1 kilogram. දැන් ඔයාලගේ වතුර කිලෝග්‍රෑම් එකක් තියෙනවා. ඒකේ තියෙන්නේ 25 Celsius. If you provide the heat for that one to become water 1 kilogram of 26 Celsius. දැන් ඔයාලට මේක පත් කරගන්න ඕන 26 Celsius. It means only 1 Celsius you need to increase in the water. පුතා එහෙනම් අපි බලමු මොකද්ද මේ high specific heat capacity කියන්නේ. The amount of heat that used to provide for 1 kilogram of water to increase the temperature by 1 Celsius. එතකොට මෙතන අපි දෙන්න heat එක. අපිට මේක 1 Celsius වලින් වැඩි කරගන්න 1 kilogram of water වල temperature එක 1 Celsius වලින් වැඩි කරගන්න දෙන්න ඕන heat එකට අපි කියනවා specific heat capacity. The reason for telling it as high, ඇයි ඒකට high value එකක් කියන්නේ? මොකද අපි දෙන්න ඕන ප්‍රමාණය ගොඩක් වැඩි. We need to provide high amount of heat to increase the temperature from 1 Celsius of 1 kilogram of water. වතුර කිලෝග්‍රෑම් එකක temperature එක Celsius එකකින් වැඩි කරන් ලොකු temperature එකක් දෙන්න ඕන කියන එක තමයි මේකේ අදහස. I think you can learn it. You learned about that one. So I'm cleaning. The next one is this. That is about how can you identify the ionic bonds. How can you differentiate the ionic bonds and the covalent bonds. කොහොමද අපි අඳුරගන්නේ මේ compounds වල ionic bonds ද covalent bonds ද තියෙන්නේ කියලා. මම කලින් නම් method එකක් කිව්වා. Normally non-metal with metal making ionic bonds as well as non-metals with non-metals making covalent bonds. හරියට නිකන් මේ වගේ මම කලින් කිව්වේ sodium chloride, that is a metal, sodium metal, chlorine is a non-metal, metal with non-metal normally make ionic bonds. But if we take HCl like molecule, hydrogen is a non-metal, and chlorine is a non-metal. Non-metal with non-metal normally make covalent bond. ඕක තමයි hint එක. එහෙම අපි most of the times මේක තමයි අපි ගන්න theory. The next thing is, the topic of this one is the properties of ionic bonds and covalent bonds. How can we determine about ionic bonds by using an experiment? කොහොමද ඔයාලා? You did this experiment in your former grades. Former grades you do this one. How to do it? You need to take a solution. Actually this is electrolysis process. You did this one in grade 9. මේකට අපිට beaker එකක් ඕන. We need a beaker. Then we need 2 carbon rods. Then you need to provide the solution. It means the compound you take for identifying the covalent or ionic bond, you need to put into this beaker. ඒකේ දැන් හිතන්න ඔයාට ඕන sodium chloride වල ionic ද covalent ද කියලා බලා ගන්න. එහෙනම් sodium chloride solution එක අරගෙන මේ beaker එකට දාන්න තියෙනවා. Then put carbon 2 rods. Then connect the circuit with connecting wires. Then fix a bulb and a battery. Actually, if the current is passing through the liquid, you can light up the bulb. If can pass the current mean, definitely the solution should contain ionic bonds. Ionic bonds තියෙන්න ඕන. Ionic bonds තියෙන්න ඕන. මේකේ ionic bonds තියෙන්න ඕන. current එකක් යන්න නම්. මොකද ඔයා ඉගෙන ගත්ත grade 9 වලදී mobile ions කියලා කියන්නේ mobile ions තියෙනවා කියලා කියන්නේ current එක අරගෙන යන්න පුළුවන් කියන එක කියලා ඔයා ඉගෙන ගත්තා. So it has mobile ions, sodium chloride solution, ඒ වගේ ඊළඟට potassium chloride solution. They contain magnesium chloride solution. They contain ionic bonds. So that if we make the solution with that kind of compound, we can conduct electricity and light up the bulb. So bulb එක පත්තු වෙන්නේ mobile ions තියෙනවා නම් විතරයි. හැබැයි අපි distilled water, if we use distilled water, glucose solution, sugar solution, we can't light up the bulb like this. මේ විදිහට bulb එක පත්තු කරගන්න නම් වෙන්නේ නැහැ මොකද? දැන් මේ විදිහට පුළුවන් උනේ ionic bonds තියෙන එක. This is the way of confirming the ionic bonds. Actually this came in one of the O-level examination. Most of the term test also come in this one. Keep remember about it. Then here, if the bulb is lighted up, we can detect ionic compounds. Ionic compounds, write it. Melting points and boiling points of some compounds. ඊළඟ එක තමයි melting points and boiling points of the compounds. Look at, I have sodium chloride in the first column, potassium chloride, water, ammonia, oxygen, ethyl alcohol, calcium oxide, sulfur dioxide, like compounds. මේ compounds වල melting point, boiling points and bond type එක මෙහෙම තියෙනවා. බලන්න, look at sodium chloride, the melting point is high, boiling point also high. Potassium chloride, melting point high, boiling point very high. Like that, calcium oxide also very high values. Look at their bond type, ionic, ionic, ionic. It means this is one of the speciality of ionic bonds. The melting points and boiling points are very high in ionic bonds because they are making ionic lattices now. Then next one, look at water. Water, then ethyl alcohol, like Puda, as well as ammonia, then this one oxygen, sulfur dioxide. Their melting points and boiling points are very low. Puda, eva adui then. water වල නම් 100 වත් තියෙනවා අනිත් ඒවා ගොඩක් අඩු. එතකොට තේරෙනවා මේවා if melting and boiling points are become low values because they are covalent bond. Covalent bond වල තියෙන characteristic එකක් තමයි melting points and boiling points become very low. Especially gases like ammonia, oxygen and sulfur dioxide contain very low melting and boiling points like minus values. ඒවා ඍණ values, minus values විදිහට මැලෙන්න. They are the specialties of the. Then the next part, the last part of the lesson is differentiation of characteristics of ionic and covalent compounds. අපි දැන් differentiate කරන්න දැනගන්න ඕන covalent and ionic compounds වල වෙනස්කම්. එතන ionic compounds ගත්තාම they are made out of the positive and negative ions. So the first one, right, they are made out of positive and negative ions. Either positive and negative ions. But covalent bonds, they are made out with atoms. They are made out with atoms. ඒවා හැදෙලා තියෙන atoms වල. මේවා හැදෙලා තියෙන positive and negative ions. Positive ions mean cations, negative ions mean anions. Second one, most of the ionic compounds dissolve in water. Second one, most of the ionic compounds dissolve in water. But for the other side, some of the covalent compound dissolve in water. Write down them. Water. The next one we learned from the previous Puta table. Third one, have high melting and boiling points. For the other sides, oppositely, have low melting and boiling points. Next one, fourth, aqueous and fused solutions conduct electricity in ionic bonds. Aqueous කියන්නේ ජලීය ද්‍රාවණ, fused solutions කියන්නේ after heating the compound we can make the liquid. That kind of solutions conduct electricity in ionic compounds, but in covalent compounds can't conduct electricity. Can't conduct electricity. The last point of the differentiation of ionic and covalent compound is, this is the fifth one, most of the ionic compounds are in solids in room temperature. Opposite to this one, in the other side, covalent bonds, most of them are in liquid to gaseous form, like ammonia. Ammonia is a gas. gaseous form. Ammonia is a gas, water is a liquid, ethyl alcohol is a liquid. That's why the most of the covalent compounds are in liquid and gaseous states. But if we take calcium oxide, lithium oxide, then sodium chloride, magnesium chloride, they are in solid form in the room temperature. When we take ionic compounds, ionic compounds, most of them are in liquid and gaseous form in room temperature. Write them in your sheet. Okay, today I explain about the lesson number 10 of grade 10, that is about chemical bonds. Hope you learnt about this lesson very well. We will meet in next day. Goodbye, children.